Hey guys, Absolute 5 here. So, today I want to clarify more, just a little bit more about the concept of infinity. And specifically, like, the limits of infinity. What does that really mean, the concept of infinity? Because it's like, infinity isn't the typical number where you just simply plug it in and it'll just work. It's an entirely different concept to comprehend. So let's elaborate more about what it is to talk about infinity. So the limit as x approaches infinity of f of x equals infinity. This is used to indicate that the values of f of x becomes large as x becomes large. So let's say if I gave you the limit as x approaches infinity, x to the third, and the limit as x approaches negative infinity of x to the third, and you're asked to find the limit of both. So let's write that process on top, because the thing is, what you're doing is this. Essentially, you want to understand what happens when you plug in values for x to the third. So let's see what happens. So let's say I gave x to be 10, right? Let's say x equals 10. So I have then parentheses 10 to the third, because that's what I was given here. So 10 to the third is 1,000. What about if I gave it 100? X equals 100, then I get 100 to the third, which is 1, 2, 3, 4, 5, 6. And if I gave x to the 1,000, 1,000 to the third is 1 billion. Okay, so if you see the pattern here, obviously it's getting huge. It's exponentially large. Well, in this terms, arbitrarily large. Excuse me, arbitrarily large. Therefore, based on this pattern, we see that this is going to get arbitrarily large, and that it makes sense that when we take the limit as x approaches as x to the third approaches infinity, it's going to become infinitely large. And similarly holds true for the negative limit. So if I gave you, just do one. If I gave you negative 10, you're still going to get the same thing. You would get negative 1,000. So you get the exact same thing for each one of these, but a negative value. So that means that means for our limit, right? As x approaches infinity for x to the third, I'm talking about for this case up here, this becomes infinitely, this goes to infinity. And for this case, what I'm talking about here is the limit as x approaches negative infinity of x to the third, excuse me, this gets arbitrarily small, infinitely. So this becomes negative infinity. So understanding the concept of infinity is not just simply just plugging it in and it should work. It's about understanding what happens when I plug in values that corresponds to the function. It gets bigger and then bigger and bigger and bigger, and then you realize, oh, it's going to get large no matter what I do, so therefore it's infinitely large. Therefore it goes to infinity. Now, that's not always the case. Some cases you have to be a little bit intuitive about how you go about plugging in infinity. I'm going to show you an example of what I mean by this. So the example I have is find the limit as x approaches infinity of x squared minus x. Now I know it's tempting. One of the properties of limits was to distribute the limit of infinity to each sign. So the thing is, let's see what would happen, right? I just say the limit as x approaches infinity of x squared minus the limit as x approaches infinity of x, right? I want to ask you guys, does this make sense? So based on our last example, this is going to get large. This is also going to get large. So the thing is, I have infinity minus infinity. Does this make any sense? No, it doesn't, because how can you have infinity infinitely? Remember, this is a notation. This is just a representation of numbers forever getting large. How can you deduct that by something that's getting infinitely small? That doesn't make any sense. Or the opposite of it. You can't just cancel these two out and just say, oh, these two are going to cancel. This here is undefined. You can't define what's going on here. This is not defined. So that's why you cannot use the law of the limits for this case here. However, let's erase this. You are allowed to fix the situation. What I mean by fix the situation, I mean you're allowed to actually factor out an x in each term. So I have an x here, and I have x minus 1 here. Now this makes more sense now. Because if I take the limit of x, right, we see that we see that both x and x minus 1 are two terms that are going to get infinitely large. Therefore, the limit of this is just going to be infinite because they're both getting large. Rather than we have infinity minus infinity, we just have two values that are going to be infinitely large no matter what we do. So this makes more sense. So I hope I explained a little bit about the concept of infinity a little bit better this time, and that infinity is such a powerful concept, and it's a remarkable field to think about, like how we can kind of not really control it, but to explain it and understand. I think that's a pretty phenomenal concept in my opinion. So anyway, that's a lesson for you guys. So I want you guys to thank you guys for watching Absolute 5. Be sure to like, share, and subscribe to this channel. Be sure to hit that bell button to get more content. And also, be sure to leave a comment. Let me know what concepts I should be talking about or anything else I should cover. But I'm still going to wrapping up calculus. We still have a whole lot of way to go before we finish with calculus. So until next time, never forget that math is infinite because there are infinitely many possibilities. Have an absolutely lovely day, guys.